DTO, a data transfer object. Interesting that Martin Fowler described the DTO in his book in 2002. This is 19 years ago. And now we will tackle that and see how it's applied to our code bases and our work. So far away, but the topic is still relevant. Today we will explore how easy it is to let it leak into our code base, what problems it could bring, and most important, how to protect the code base from it. Let's start with what is DTO. The data transfer object is actually what we send over the wire. We send to an API and we retrieve back from API. For example, in our environment in George, the most known probably data transfer objects, payment order or standing order or transaction or maybe contact or electronic invoice. We operate on all these objects. When we fetch a list of transactions, for example, we receive a list of transaction DTO. Or when we create a new standing order, we send an input in a JSON as a JSON payload and retrieve back a DTO with created standing order. Let's explore some of our DTOs and issues, how they appear in our code base. So the first one I wanted to look at is, for example, payment receiver. Here are two properties that API retrieves as BBAN, which in terms of banking is local bank account number, and IBAN, which is actually international bank account number. One is retrieved with type false, another one with string. Another, for example, DTO could be standing order that arrives to us with a number inside. And a number in API is actually a unique ID of the standing order. But we developers are used to work with ID property for a unique identifier of some resource, right? Here, the API is using number. Or for example, there are these kind of properties which are defined by a particular country API. Sometimes they add some custom properties, which are not easy to handle because we don't know when this shall be presented, when not, and we let it leak into our code base as this, in this format. Another one that I wanted to show, secondary ID is Signy, the simple first name and last name are lowercase, and the user ID is camel case. But why there is a camel case used in the same API response for one type of property and for other properties the lowercase? Another thing that I wanted to look at the problems is not just property names. These are maybe minor and we can live with them, but the values that DTO provides. An example, I want to look at domestic payment order from our code base, and it provides receiver address. And the value interesting is an array of strings. If I look at this code and try to learn this code, how do I know where in this array shall be saved the street, where the city, where the postal code or the country code? Or it's maybe just one item with everything included. No clue, right? Or if we look at transfer date, it receives from the API as a string, and that's okay. Maybe it's an ISO string, maybe it's some other date string or so, okay? But if we let these kind of string leak into our code base and need to operate it, we anyway need to convert it into some other format that it's easy to change, to maintain, to update, and so forth. The same for expiration date, for example. Or if we look at back payment receiver, DTO, there's a currency, interesting. And the currency is a singular name, but the value is actually an array of strings. Why it's singular? Why it's not plural if the value is plural? Weird. This creates confusion. And for example, during pull request requests, we face such situations. Or we can look at standing order, another interesting thing. Standing order, DTO, there is execution interval. And execution interval points to some enum of execution intervals. These values, they are arriving within DTO from an API. Look at these two. This half a year or semi-annual. Aren't they represent the same thing? It's half a year, right? Or yearly and annual. The same thing. The problem is, since George is deployed to many countries, we are consuming multiple APIs of these countries. And every country decided that for one country, for example, for Austria, the interval will be used as annually, but for another country, for example Slovakia, they decided yearly. So DTO, depending on the country, receives us different strings as the values for these intervals, and this all goes into our code base, and we JavaScript developers shall somehow deal with these differences. This adds complexity. This spends a lot of our time, okay? What I lead to is that we don't control DTO data structure, okay? okay? Because it's external and it requires a lot of effort to change it, because there might be multiple consumers, and enforcing multiple parties to adapt to the change is a workload. Again, what we can control is a domain object. At the left side we have a DTO that I was just looking at with you, and at the right side we have a domain object. As you can see the comparison, instead of a number we put an ID here, and that becomes clear that it's ID, unique ID identifier for the resource. For example, for receiver address, here we don't use anymore, but some other object which will have a respectful properties like street, postal code separately, or a country. For example, for max iterations, I don't know why DTO from the API sends us it as a string, but we fix it in domain object with number because that's max iteration. The same with date of repetitions here. And even this interval, as I shown you, this interval which creates confusion with different values representing actually the same meaning. Here in domain object there is just one, which is just clearly half yearly, and that would be obviously cool if we could have this domain object within our code base, because they are much easier to maintain. Okay, they have a static type. Beyond that, this domain object has some functions that operates the business logic for a domain object. Okay, that's cool, but domain object is kind of separate thing for now. I just wanted to introduce it. And to sum up it a little bit, I wanted to say that domain object could be within our code base. We could own it, we could maintain it. And since this object could be owned by our developers, not an API, it's easy to change it. The domain object doesn't require significant effort to change. We own it, we control it, we can easily change it. This is a big beneficial. And now I want to talk a little bit about the cooperation between our code base and the API. Let me draw a quick system design. This is our code base, and we want to communicate with an external API here. For example, to create a standing order. For this, we create a method somewhere on the boundary of our code base that will pass a JSON payload into the API and so. So we, per DTO, data transfer object in our code base, pass it to this function that actually makes an API request, sends the DTO to the API. API expects it because DTO is with all expected properties and values, and it retrieves back a created standing order in a format of JSON, and we let it leak into our code base and then operate, display it in a certain way, let user edit it, and so forth. So DTO is in this place, okay? And now, what if we introduce a domain object, the one which is comfortable, the one that I shown you with all the clear property names and values and methods nearby, everything in place. So what if within our code base we would operate on this comfortable object for a standing order, and as soon as we want to pass it to the API, we could introduce a DTO converter. That's a domain object into DTO converter, okay? It's a gateway between our code base and an API. So we send in our domain object and it's converted within a converter into DTO, which satisfies and fulfills an API requirements. So API gives back us as DTO, and here, instead of letting it leak in, we are putting another converter on the boundary of our code base. As soon as this API retrieves back the DTO with all these not comfortable, let's say, property names and values to work with, we convert it into a domain object, and it dives into our code base, and we can operate on it much easier. As soon as we need another round, we again pass it to the API converter. It goes through API, responses back, and within our code base we certainly have a domain object. And this actually here, a converter, which is domain converter that converts DTO into domain object, works like a filter. Okay, you receive in a DTO from API, and then you filter it to a more proper, or map it to a more proper value, which is DO, which is comfortable to work with. And then within your code base there could be multiple domain objects which are comfortable to work with, and then you operate within your code base with these objects. Much easier, much comfortable than DTOs. So we have only one layer here, the converters, that actually knows the details about the DTO. The code base doesn't know about DTO nuances. Our code base operates on a domain object. So this is cool. Now I want to share some takeaways from what I just shown. I hope it was pretty clear. So DTO, it contains a data structure that sometimes has clarity and confusion. Property names are not accurate, or values have primitive types, which maybe even evaluates primitive code smell. So it's hard to operate these values. It takes time. We don't control the domain data transfer object. It's external. It requires a lot of effort to change. On the other hand, domain object. This is what we can control. We can fully manage because we develop it. We develop a converter that actually creates these domain objects and lets them into our code base, protecting it as the converter protects it as a shield, our code base from the DTO, ensuring that it's easy to operate on a domain object, easy to change, adjust, and so forth. DTO is not an object to work with. We can convert it to a domain object in favor to keep our code base evergreen and comfortable for everyone to work with.